Hello and welcome to all students. In this lecture, we learn about differentiation and we study what is meant by tangent plane, what is meant by tangent plane and tangent plane and normal to the given curve. Let us start what is meant by tangent plane. So first of all we define what is mean by tangent plane. So write the definition. Let S be a surface in R3. Let R0 is equal to x0, y0, z0 be a point in S. Consider all curves in S passing through R. So as S is a surface in R3 and R0 is a point on that surface, then let us consider all those curves in S passing through the point R. So therefore there are infinitely many curves on S which are passing through the point R on the surface S. If there exists a plane such that it contains all tangent lines at the point R0 to all curves passing through R0 in S, then such a plane is called as tangent plane to the surface S at point R0. Okay, the concept of tangent plane is very simple. Okay, so if S is a surface in R3, suppose surface is a sphere and R0 is a point on that sphere, on the surface of sphere, then the plane which is tangent to that surface at point R is called as a tangent plane. Or by definition, if we explain it, then if we have a sphere, a surface of a sphere, and R0 is a point on that sphere, then we draw all the curves on that surface of sphere passing through the point R. Again we draw all tangents to all these curves at point passing through the point R0. We draw all tangents at point R0 to all these curves, and the plane which contains all these tangents, that plane is called as a tangent plane to the given surface. Okay, so the concept is very simple. Now let us write for one theorem. Let capital S be any non-empty subset of R3, and let F from S to R2 be a scalar field differentiable on S. So here is one correction. Let F from S to R, so there must be R, not R2. Okay, so let F from S to R be a scalar field, differentiable on S. Let L of K is equal to, it is the set of all those x belongs to S such that f of x is equal to K. K is belongs to R, it is a constant, be a level surface. Let C be a curve which lies on the surface and passing through point E. Then gradient of f at A is a normal to the curve at point A. Okay, so it is also very easy concept of normal, finding a normal to the given curve on a given surface at a given point. Okay, normal means a perpendicular vector to the given surface at a given point. Okay, it is a very simple concept. Perpendicular vector to the given surface at a given point. Okay, and that vector is gradient of f at a. So keep in mind that vector gradient of f at a is a normal vector to the given curve at point A or to the given surface at point A. Okay, equation of tangent plane. So if n equal to n1 comma n2 comma n3 is a normal vector to a plane passing through A is equal to a1 comma a2 comma a3 in R3, then the equation of plane is given by n dot x minus a is equal to 0. So once again, if n is equal to n1 comma n2 comma n3 is a normal vector to a plane passing through a equal to a1 comma a2 comma a3 belongs to R3, then equation of plane is given by n dot product with x minus a is equal to 0. So obviously vector n and vector x minus a, these two vectors are perpendicular to each other, and therefore their dot product is always equal to 0, and that becomes the equation of the tangent plane. That is vector n1 comma n2 comma n3 dot product with a1 comma a2 comma a3 is equal to 0. The equation of tangent plane to the level surface f of x comma y comma z is equal to k. We can write, so see here in the previous slide, the equation of tangent plane is obtained like this. So actually here must be dot product of a vector n1 comma n2 comma n3 with the vector x minus a1 comma y minus a2 comma z minus a3 is equal to 0. That must be our equation. So the equation of tangent plane to the level surface f of x comma y comma z is equal to k passing through the point a equal to a1 comma a2 comma a3 is given by, so that equation of tangent plane is given by the, okay, so gradient of f of a is a normal vector and x minus a1 y minus a2 and z minus a3 is a vector in that surface. Therefore the gradient of f of a and x minus a, y minus a2, z minus a3, these two vectors are perpendicular and therefore their dot product is 0. Therefore gradient of f of a dot product with x minus a1, y minus a2, z minus a3 is equal to 0. But gradient of f of a is nothing but dou f by dou x at a, comma dou f by dou y at a, comma dou f by dou z at a, dot product with x minus a1 comma y minus a2 comma z minus a3 is equal to 0. Now on the left hand side, take a dot product of these two vectors, and we know that dot product of these two vectors is a scalar quantity, and the resultant is dou f by dou x at a into x minus a1 plus dou f by dou y at a into y minus a2 plus dou f by dou z at a into z minus a3 is equal to 0. So this is the required equation of tangent plane to the given surface at a given point. So afterwards we will solve some problems based on this equation of tangent plane. Okay, so now let us see the equation of normal line. or equation of normal, okay, equation of normal line to the given surface. Okay, so equation of normal line to the given level surface f of x comma y comma z is equal to k at point a is equal to a1 comma a2 comma a3 is given by x minus a1 upon fx at a is equal to y minus a2 upon fy at a is equal to z minus a3 upon fz at a. So based on this equation, also we are going to solve some problems. Let us take one example. Question number 1. Find the derivatives of z with respect to t if z is equal to 3x square 3x cube y plus 4y cube and x is equal to sine of 5t comma y is equal to cos of 5t. Also find dz by dt at t is equal to pi by 2. Actually, this problem is a problem based on the chain rule of the differentiation. Okay, so let us try to solve this problem here. No problem. So answer of this question is, given that a function z is equal to 3x cube into y plus 4y cube and x is equal to sine of 5t, y is equal to cos of 5t. So here we observe that z is a function of two variables x and y, and x and y, they are again a functions of variable t. So this shows that z is a function of xy and xy, they are functions of t. Means z depends on xy and x and y both depends on the variable t. So that is z is a function of xy and again x and y are functions of variable t. To find dz by dt we use chain rule. To find derivative of z with respect to t we use a chain rule, so like this. Therefore we know that the chain rule is dz by dt is equal to dou z by dou x into dou x by dou t plus dou z by dou y into dou y by dou t. Or we can write this chain rule like this: dz by dt plus dou z by dou x into dx by dt plus dou z by dou y into dy by dt. So here the change is only, we are instead of writing dou x by dou t we are writing dx by dt, because and instead of writing dou y by dou t we are writing dy by dt. So because of x and y, they are functions of a single variable t, they are not functions of several variable. Therefore while denoting derivative we use total derivative dx by dt like this, not a partial derivative. Okay, so to find dz by dx, let us try to find all the right hand side quantities. Here we find all derivatives one by one, as we have z is equal to 3x cube into y plus 4y cube and x is equal to sine of 5t comma y is equal to cos of 5t. Dou z by dou x means partial derivative of z with respect to x. So while finding derivative of z with respect to x, let us find a normal derivative with respect to x, but at that time keep y and z constant and find derivative. So if I treat y and z constant, if I treat y constant, then we have 9x square into y plus 0 is equal to 9x square into y. So dou z by dou x is equal to 9x square into y. Now find out partial derivative of z with respect to y. So while finding derivative of z with respect to y, let us keep x constant or treat x constant and find derivative of z with respect to y. So derivative is 3x cube plus 12y square. Now find out derivative dx by dt. Dx by dt means derivative of x with respect to t, and x is sine 5t and its derivative with respect to t is 5 times cos t, 5 times cos of 5t. Also find derivative of y with respect to t, it is equal to minus 5 into sine of 5t. Now we write dz by dt is equal to, so it is equal to dou z by dou x into dx by dt plus dou z by dou y into dy by dt, and it is equal to, now let us put the values of all these derivatives. So our next step is equal to 9 into x square y into 5 times cos of 5t plus 9 plus 3x square plus 12y square into minus 5 into sine of 5t. In third step, it is equal to, if I take a product of the constants, then it is 45x square into y into cos of 5t minus 15x cube into sine of 5t minus 60y square into sine 5t. Now we find values of all functions at t is equal to pi by 2. So x is equal to sine of 5 pi by 2 and y is equal to cos of 5 pi by 2. But we know that the value of sine 5 pi by 2 is 1 minute. So the value of sine 5 pi by 2 is 1 and the value of cos 5 pi by 2 is 0. So we find the derivative of z with respect to t at point t is equal to pi by 2. So let us put all these values here, and in the final step we will find that, okay, see here, we know that value of sine pi by 2 is 1 and the value of cos pi by 2 is 0. That's why if I put all these values here, then finally we get the answer minus 15. Therefore dz by dt at t is equal to pi by 2 is minus 15. Thus we have dz by dt is equal to minus 15 at t is equal to pi by 2. Now let us take second example on tangent plane and normal line. Find the equation of tangent plane and normal line to the surface z equal to 9x square plus y square plus 6x minus 3y plus 5 at 1, 2, 3. Let us write the answer of this question. So given that surface f of x comma y comma z is equal to 5, therefore f of x comma y comma z will be equal to minus 9x square minus y square minus 6x plus 3y plus z. So that is our function f. Now to find out point A is equal to 1, 2, 3, it is a point on given surface. Now the tangent plane to the surface f of x comma y comma z is equal to 5 at point A equal to 1, 2, 3 is given by, Now this is the formula to find the tangent plane. Dou f by dou x at point E into x minus a1 plus dou f by dou y at point E into y minus a2 plus dou f by dou z at point E into z minus a3 is equal to 0. So let us call this equation be a star equation. We find dou f by dou x is equal to minus, okay, we find dou f by dou x now. So as function f is known to us, just find out partial derivative of f with respect to x, and that partial derivative will be equal to minus 18x minus 6, and this will implies the value of partial derivative of f with respect to x at point 1 comma 2 comma 3 is equal to minus 18 into 1 minus 6 is equal to minus 24. Similarly, find partial derivative of f with respect to y, and it is equal to minus 2y plus 3, and the value of dou f by dou y at point 1 comma 2 comma 3 is equal to minus 1. And if let us find the partial derivative of f with respect to z, and it is equal to 1, and the value of dou f by dou z at point 1 comma 2 comma 3 is equal to 1 also. Now the equation of tangent plane is star becomes, and it is equal to minus 24 into x minus 1 plus minus 1 into y minus z plus 1 into z minus 3 is equal to 0. So if we simplify this left hand side, we will get minus 24x plus 24 minus y plus z plus 2 plus z minus 3 is equal to 0, and finally we get the equation minus 24x minus y plus z minus 23 is equal to 0, and this is a required equation of tangent plane. So let us stop our lecture here, and we will discuss the remaining part in the next lecture. Okay, thank you very much.